Now, for this lecture, we will be discussing yung lipids or yung tinatawag nating fats. And the outline of our discussion or of our lecture for lipids will include the structure of lipids, the function of lipids, the classification of lipids, and also its digestion, absorption, and metabolism. So let's start with the structure of lipids, no? So yung lipids natin, they are actually organic compounds. Parang din yung ating proteins and carbohydrates. So they have a carbon atom in their structure, in their chemical structure. As you can see here, so ang daming carbons. And they are also esters, no, of glycerol and fatty acids. So, yung basic unit ng inyong lipids or fats ay composed of glycerol and fatty acids. Okay? So, iyon, we call that as simply triglycerides of fatty acids or just triglycerides in short. So, this is what makes the basic unit or what constitutes the basic unit of your lipids or fats. So this is what a glycerol looks like, and this is your fatty acids. Okay, so we enlarge that. We have here a hydrophobic fatty acid, meaning to say hindi siya miscible in water. Okay, so hydrophobic, water fearing. Okay, and your glycerol and phosphate group, which is, or this head, we call this actually the hydrophobic tail, and this head constituting your phosphate group and glycerol is a hydrophilic, meaning to say this is water-loving na part. Okay? So yung ating, so balik tayo no, dito sa organic compound. Aside from having carbon atoms in its chemical structure, isa kasi siyang hydrocarbon. Okay? So, recall your organic chemistry, it's hydrocarbon, no? And kapag sinabi nating esters, recall the formula of your ester, RCOOR. Tama? So, yung R na yon, yung R present in the formula or chemical structure of your ester, RCOOR, yung R, yung ating hydrocarbon. Okay? So, wag kakalimutan, ang basic building blocks ng ating lipids or fats are your triglycerides or yung glycerol and fatty acids. Okay? Kapag tinanong ko what comprises your triglycerides is your glycerol and fatty acids. Okay? So, tatlo ang fatty acids na nakakabit sa isang molecule ng glycerol. Now, bakit kaya? You might be asking, bakit nagiging hydrophobic ang tail and bakit nagiging hydrophilic ang head? Nagiging hydrophobic ang tail ng fats or ng triglyceride because of the presence of your methyl groups or your CH3. And recall that your methyl groups are non-polar. So that makes them hydrophobic. In contrast to your phosphate group, which is a polar molecule, then that will make it hydrophilic. Okay? Hydrophilic siya in nature. Next, proceed tayo no, sa functions ng lipids. Since yung composition ng ating triglycerides or yung fats natin ay mostly hydrophobic, okay? So they are insoluble in water. So even if some parts of the structure ng ating lipids or ng ating triglycerides ay hydrophilic, still they are insoluble in water as a whole, okay? But they are soluble in organic or non-polar solvents, okay? Such as yung ethers natin, benzene, hexane, and chloroform. Okay? So, ito yung example natin ng, this is actually the structure, no? So, parts of your cell membrane. So, they comprise, yung ating cell membrane comprise siya, tinatawag actually siyang lipid bilayer because what comprises the structure of your cell membrane or your plasma membrane are actually lipids. Okay? Lipid bilayer siya. two layers. Okay, two layers of lipids. So, yung ating head niyang lipids natin ay naka-orient or naka-direct towards the water kasi ang ating head ay hydrophilic or water-loving. So, that's polar head. And your tails, they are directed away from the water since they are hydrophobic. So, ang function ng ating lipids ay they act as electron carriers in enzymatic reactions. Okay? And they, sabi ko nga kanina, they are components of your biological membranes or cell membranes. And yung ating vitamins A, D, E, and K or yung ating fat-soluble vitamins, so your ADEK, they are your fat-soluble vitamins. So, na-absorb lang ang ating vitamins na A, D, E, and K in the presence of fat. Kaya, yung mode or route of administration for injecting vitamins A, D, E, and K ay subcutaneous. Okay? Kasi sa subcutaneous, present doon ang fat. Okay? So, kailangan nila ng fat globules or fat molecules para ma-absorb itong mga vitamins sa bloodstream. Okay? So, ayan, component ng cell membrane. And they also help in regulating temperature, okay? Insulation, lubrication of joints, and delays the sensation of hunger. Okay? So, yung temperature regulation, nakakatulong yung fats natin para, so yung cold temperatures kasi, yung cold temperatures or lower temperatures triggers yung ating body or yung fat cells in the body to release stored energy. Okay? So, they release stored energy in the form, of course, of heat. Right? What else? Delays the sensation of hunger because ang primary na function ng lipids natin is to supply energy. Okay? Supply energy. So, sabi natin sa carbohydrates, they also supply energy. Sa proteins natin, they also supply energy. Okay? And yung lipids natin, they also supply energy. Okay? Fats, alam naman natin yun, no, na fats are source of energy. They are actually referred to as concentrated source of energy. Why concentrated? Kasi sa isang gramo ng fat or lipid, meron niyang 9 calories. So, more than double. Okay? More than twice of the calories produced from carbohydrate metabolism. Okay? Or protein metabolism. So, mas mataas yung calories na nakukuha natin sa fat. Tama? So, dahil mataas yung calorie from fat, meron yung limit naman, no? Kahit source of energy yung fat, there will always be a limit, no? Sa inclusion doon sa diet ng, hindi lang ng tao, but pati na rin sa animals. Okay? Proceed tayo sa classification, no, ng lipids. So, as you can see here, we have a diagram showing you how lipids are categorized. So, we have simple lipids, compound lipids, and derived lipids. So, most probably, the lipids are classified according to complexity. Okay? So, yung simple lipids natin, examples are fats and oils, and then yung waxes. Compound lipids, we have phospholipids, glycolipids, etc. until glycosphingolipids. So, parang ang sinasabi sa compound lipids is hindi lang lipid or hindi lang fats ang component ng compound na to, but there are also other, parang dito, phosphoric acid. Glycolipids, present, combination of carbohydrate and lipids. Lipoproteins, combination of protein and lipids, etc. Okay, so and then here we have derived lipids. Examples would be the steroids, terpenes, and carotenoids, as well as your fatty acids. And your fatty acids, your very common fatty acids, no? Examples or can be divided into saturated fatty acids and unsaturated fatty acids. And yung unsaturated fatty acids natin still categorized into two, monounsaturated fatty acid and polyunsaturated fatty acids. So for you to further familiarize yourselves with each of these many types or many kinds of lipids, then please answer your first assignment for Ansay 102, and that is to define the different types of lipids listed in this diagram. Okay, dito sa slide na to. Okay, so proceed tayo. So this is another classification of fatty acids. So sinasabi lang din, pareho lang yung, so mas madami kasi yung mas elaborated ang nandito, mas specific. So this is just another form or another way of classifying the lipids. This is also another one, so mas simple siya. So classify niya yung lipids based on the presence of glycerol, whether it is glycerol-based or non-glycerol-based. Okay? So, kung mapapansin ninyo, itong non-glycerol-based natin, ito yung ating mga derived lipids natin. Okay? So, ibig sabihin, hindi sila glycerol-based, yung mga derived lipids natin. So, you see, glycerol-based, we have simple and compound lipids, parang lang din yung kanina. So, kung i-compare mo siya sa ating first diagram, so your simple lipids and compound lipids, these are your glycerol-based. And then your derived lipids, ito na yung ating non-glycerol-based. Okay? So just to show you how they categorized. So this actually came from different authors. That's how they categorized or classified the lipids. Now, let's focus our attention to fatty acids. Specifically, yung ating saturated, the difference between saturated fatty acid and unsaturated fatty acid. Okay, so they are actually of importance, or of relevance. Okay, so the manner of classifying, yung fatty acid natin into saturated and unsaturated is that yung presence, kung makikita na yung presence or absence of double bonds. As you can see, sa saturated fatty acid, wala kayong makikitang carbon-carbon double bond. So lahat ng mga carbons natin are joined together by single bonds. Alright? Yung ating unsaturated fatty acids, so merong carbon-carbon double bond. So some of the carbon atoms natin are joined together by double bond. Now, your unsaturated fatty acid, sabi natin, of two types, mono, unsaturated. So, this is an example of a mono-unsaturated fatty acid because you can only see one double bond between two carbon atoms. Okay? This one is an example already of a polyunsaturated fatty acids because two or more because of the presence of two carbon-carbon double bond. Okay? So, yung polyunsaturated fatty acid natin, it starts from two double bonds, okay, until many. So, from two or more double bonds. Okay? So, ito, ang clue natin para hindi natin ma-interchange or para hindi tayo ma-confuse kung ano ang itsura ng saturated and unsaturated fatty acids. Kapag kasi saturated fatty acids, fully saturated. Okay? Fully saturated, fully distributed ang ating hydrogen atoms. Ayan, makikita ninyo. Lahat sila merong hydrogen atoms. Kumpleto. Okay? Kumpleto. Now here, hindi complete yung ating hydrogen atoms. Okay? Hindi fully saturated. Ibig sabihin dito kumpletong-kumpleto, fully saturated. We have 1, 2, count it. Okay? This one, hindi, konti lang. So, unsaturated, that's just the opposite of your saturated fatty acids. Okay? So, ito, mas hindi saturated in fatty acids. So, I hope you know what I mean with saturated and unsaturated with hydrogen atoms. Okay? So, ito, another difference is that sa saturated fatty acid, straight chain ang itsura. Okay? Straight chain ang itsura. Now, you might be arguing, ito naman ay straight chain din, no? Straight chain yung itsura niya. But, in reality, na-straighten lang to actually. So, kapag kasi may double bond na present ang isang structure or, kapag present ang double bond sa structure ng isang compound, tendency is ganito, mabibend. Okay? Mabibend ang itsura ng compound na yon. Okay? So, ito, Yung saturated fatty acid, linear, straight chain siya. Okay? Tapos, yung pagkaka-linear and straight chain niya na fatty acid, that makes it more, tawag dito, packed, mas napapackage, mas fully packed or tightly packed ang fatty acid na to, or yung mga molecules ng saturated fatty acids, mas tightly packed sila, okay, in the membrane, okay. An example natin ng saturated fatty acid, yung mga fats galing sa meat, tulad ng fat from beef, or we call that as tallow. You call the fat from pork as lard, okay? Yun namang unsaturated fatty acids natin. Now, balik na tayo sa saturated fatty acids. Saturated fatty acids, straight chain. Yung pagka-straight chain nila, that makes it them tightly packed. And then yung pagka-tightly packed nila, that makes them solid. No? Solid at room temperature. Okay? So, mas solid ang ating saturated. Ito namang unsaturated natin, because of the presence of the double band, that makes them bent. So, ibig sabihin, hindi sila masyadong tightly packed in the membrane. Okay? Pati rin dito, hindi sila masyadong tightly packed in the membrane. And that makes them liquid at room temperature. Okay? So, ano yung mas maganda kaya? Yung saturated fatty acid or the unsaturated fatty acid? So, mas maganda yung unsaturated fatty acid. Okay? Although this is not stable. So, mas stable ang ating saturated fatty acid. Alright? So, mas maganda yung unsaturated fatty acid natin. So, parang mas healthy. No? Mas healthy sila. Bakit? Because mas madaling i-break mas madali yung breakdown actually ng unsaturated fatty acid. So, mas mahirap i-break or i-hydrolyze ang bonds na single bonds, okay? Mas mahirap i-hydrolyze ang ating single bonds. Mas madaling i-break or i-hydrolyze ang ating double bond, okay? So, the breakdown for unsaturated fatty acids is relatively much faster. So, mas maganda yon kesa naman sa mahirap na i-break. Okay. Now, proceed tayo. So, these are the two types of your polyunsaturated fatty acids. We have the omega-6 and the omega-3 fatty acids. Tinawag siyang omega. Tinawag siyang 6 kasi nasa number 6 na carbon atom yung double bond. Ang unang double bond rather. So we count. Saan tayo magsisimulang mag-count? We start from the methyl group. Kung saan present yung methyl group. So we have here the methyl group. So you assume na since this is yung structure niya hindi present kung nasaan yung C at nasaan yung H, we assume na here we have the C. Tama? What you have learned in your organic chemistry, you have here the C. And how many bonds para makomplete ang ating carbon or para maging stable ang ating carbon? We have dapat 4. So 4 bonds dapat ang i-attach natin rather sa isang carbon. So we have you 1 here, and then meron pang 3 na hindi natin nakikita. So, yung 3 na yon na bonds, merong naka-attach na 3 hydrogen. So, of course, C tapos H3, that will become your methyl group. So, your methyl group is here. You first count from the carbon or yung sa first methyl group. So, 1, 2, 3, 4, 5, and 6. Kaya siya natawag na omega-6 fatty acid. Okay? Same is true here. You count here. Magsisimula tayong mag-count dito kasi nandito ang ating methyl group. Okay? This is your what? COOH group. Okay? Or your carboxylic acid group. This one, no? 1, 2, 3, 4, 1, 2, 3, 4, 5, and 6. So that's your omega-6. Okay? So arachidonic acid is an omega-6 fatty acid. Linoleic acid is an omega-6 fatty acid. And then your omega-3, saan natin makikita ang unang double bond? Doon sa third carbon from the first methyl group. So this is your methyl group. We count here 1, 2, 3. Okay, carbon 3. Here, 1, 2, 3, carbon 3. 1, 2, 3, carbon 3. That is your omega-3 fatty acids and omega-6 fatty acids. Okay, so meron tayong tinatawag na essential fatty acids. Of course, that means parang lang din siya yung essential amino acids and non-essential amino acids. Okay, so kapag sinabi nating essential fatty acids, of course, that is not synthesized by the body or of the animal body. Kaya kailangan siyang i-provide in the feed or in the diet of the animal. Okay, so the two essential fatty acids in all mammals, so that would include your monogastric animals and your ruminants, we have here the linoleic acid and the linolenic acid. Okay, so linoleic acid is a type of what? Of omega-6 fatty acid. And your linolenic, kasi 1, 2, 3, 4, sorry, 1, 2, 3, 4, 5, 6, 7. I will double check, but this should be an omega 1, 2, 3, 4, 5, 6, 7. Parang nasobrahan, no? Nasobrahan. But this should be omega 6 and this should be omega 3. Okay, so tama ito. 1, 2, 3. Linolenic acid is an omega 3 fatty acid. So these two are essential. Okay? Meron tayong arachidonic acid na essential fatty acid, but this is only essential in the case of your carnivores, of your dogs, of your cats. But since we are focusing on farm livestock, ito lang, linoleic acid and linolenic acid. Okay, so proceed tayo. So, other common fatty acids, we have palmitic acid. So, these are examples, no, present in animal tissues. We have palmitic acid, palmitoleic acid, etc. So, this one, ito yung bilang ng carbons present in this fatty acid. 16 carbons. And yung 0 na yan, 0, what's that? Straight chain. So, palmitoleic, 16-1, CH. Okay, so what else? Palmitoleic is 16-1, so 16 carbon, no? Stearic acid, 18 carbons. Oleic acid, 1 carbon. Okay, linoleic, yun ang ating, yan, sinasabi ko kanina, N6, that also means omega. Omega-6 fatty acid, this is your omega-3 fatty acid. And this is your omega-6 fatty acid. Also, omega-3 fatty acid. Okay. Kaya pala ito naging 0 because wala siyang double bond. Okay. Ito wala ding double bond. Okay. Kaya siya saturated. Ito ay saturated fatty acid. Example, 0 meaning walang double bond. Ito walang double bond. Okay. Yan, 6 ang double bond, 4 ang double bond, etc. Okay. Now, we also have yung tinatawag nating cis and trans fatty acids. So, if you're familiar with your trans fat, yun yung tinatawag natin. Yun yung short term natin for trans fatty acid. Okay. So, if you recall your chemistry again, yung organic chemistry natin, cis fatty acids, kapag cis, pareho yung location, no? Pareho yung location ng ating H. Okay, ng ating H or hydrogen atom. Makikita sila on the same side. That will be your cis fatty acid. Yung trans fatty acid, you can see, magkaiba sila ng position. Okay, they are not located or situated or they are not attached on the same side. Yun yung ating tinatawag na trans fatty acid. Now, your trans fatty acid ay, if you are familiar, ito yung worst type, no? Worst type of fat or yung trans fat natin that is actually considered as the worst type of fat because they behave. Kahit meron silang double bond, kahit meron siyang double bond, di ba, ang tawag natin sa fatty acid na may double bond, that is unsaturated fatty acid, but because they are trans fatty acid, they behave like saturated fatty acids. Okay? Or they behave like saturated fats. And ang saturated fatty acids natin, they are stable, more stable than your unsaturated fatty acids. Kaya kapag mas stable siya, mas mahirap i-break. No? Mas mahirap i-break or mas mahirap i-hydrolyze ang fatty acid na yon. And saan natin nakukuha yung trans fatty acid or yung ating mga trans fat? They are mostly present or they are mostly derived in processed foods. So, yung mga natin, no? Processed foods tulad ng junk foods, ano pa ba, mga hotdogs, chichirya, what else? Ano pa ba? Margarine. So, yung margarine natin, kung makikita ninyo, kahit walang nakalagay, as you can see here. So, these are processed foods. Kahit wala siyang nakalagay, sinasabi, trans fat natin ay 0 gram. Yan, pati itong margarine natin, 0 gram. Do not believe that because these are your processed foods. And what they do with the vegetable oils that they use ay nag-undergo kasi yung ating vegetable oil or ginagawa nila is partial hydrogenation. Okay? Partial hydrogenation of the vegetable oils. Ano yung importance ng partial hydrogenation? Para ma-prolong nila yung shelf life ng pagkain. Okay? Para bakit kailangan i-prolong yung shelf life ng pagkain? Kasi kapag present or yung fats kasi or yung lipids natin or even yung oils, madali silang ma-spoil or madali silang maging rancid or mapanis. Kaya ang ginagawa sa mga pagkain na to, ini-increase or prolong yung shelf life. And syempre, ini-stabilize nila yung flavor ng mga processed foods na to. Kaya, nagkakaroon or yung partial hydrogenation ng mga fats na yon or ng oils na yon nagiging or nakakapag-produce ng trans fat. Na ganito yung itsura. And kapag kasi trans fat, mas stable, mas mahirap maging rancid ang pagkain, ang processed foods. Yun yung tawag dito, yung rason kung bakit ginagawa nila yung partial hydrogenation. Okay? What else? Unfortunately, yung trans fatty acid, present din yan, sabi ko kanina, sa animal or sa animal tissues, no? Sa meat and meat byproducts, dairy, present din yan. But in smaller amounts nga lang. Okay? Smaller amounts than the trans fat present here. Kahit nilagay na 0 yan, meron. Kasi this is processed. These are processed foods, rather. What else? Next. Now, what is the reason bakit nagdadagdag tayo, no, ng fat sa animal diet? Not necessarily yung trans fat, since yun yung huli nating na-discuss yung trans fat. But why do we add fats to animal diets? Because yung to serve yung purpose ng fats, they supply energy. They serve as a source of energy to the animals, most especially kapag kulang ng carbohydrates doon sa kanilang diet. So, there are several studies conducted focusing on the addition of fats and oils to feeds or to diets of animals tulad dito. One study showed that the addition of fat and oil to layer feeds had at least 5 additional effects with increasing levels of crude fat and added fat or oil. So, una, in-increase niya yung energy content of the diet and therefore, kapag na-increase yung energy content of the diet, that increases the performance. Egg performance, laying percentage, etc. Number 2 effect is increased egg weight due to fatty acid profile. Third, improves liver health and reduces fatty liver syndrome. Fourth, increases palatability of dusty mash feed. Okay. Number 5, kasi nga, mas sabi nila, most especially kapag kumakain kayo ng baka, ano yung hinahanap? Yung fat, fat, mas kunada no kwa, mas jay baka no natabtaba. Okay? So, that increases, parang ganito din yon. It increases the palatability of dusty mash feed. Number 5 is reduces heat increment in heat stress situation. So, yun yung nakita nila sa study na ginawa. Another study is So yun, yung tiningnan natin dito is in layer feeds. Dito naman sa broilers. So usage of fat in broiler nutrition. So this study was conducted in 2007 by Dube. Okay, so Dube. And nakita nila na yung fat included in the diet increases. Same lang. So increases the amount of energy provided to the bird. And aside from that, additional na benefit na derive ay it helps reduce dust which may have adverse effects on bird health. So yan, sinasabi natin kanina. Lalong-lalo na kung ang form ng feed na binibigay natin is in mash form, not in pellet form. So these are also other studies, no? Investigating the effect of early exposure of lipids and its impact on progeny chickens, immune or inflammatory responses. So ayan, so madaming studies. Another is overall effects of early exposure of omega-3 lipids through hatching egg in progeny chicks. So nakita nila na merong provision of energy even at the start ng or even if at day old pa lamang, no, yung ating chicks kasi upon hatching. What else? Okay, so proceed na tayo sa lipid digestion and absorption in non-ruminants. So we're already done with lipid structure, with lipid function, classification of lipids, why do we need to add fats or lipids to the diet of animals. Now we proceed to digestion, no? Digestion, absorption of lipids in monogastric animals or in non-ruminants. Okay, so unang-una, merong lipase. Ang importante kasi in lipid digestion, the presence of an enzyme. So enzymes are needed to further or to speed up yung chemical reaction. Pati na rin sa digestion of carbohydrates natin and proteins, we need enzymes. So, ang kailangan natin sa carbohydrates is yung amylase natin, etc. And other enzymes that are secreted in the small intestine and stomach. And yung proteins natin, kailangan natin ng peptidases, etc. Dito sa lipids, ang kailangan natin na enzyme to help further yung breakdown ng lipids natin is yung lipase na tinatawag. So, lipase this derived from lipids, okay? However, so nagproduce ang ating saliva ng lipase, so we call that as lingual lipase. But yung lipase na pinoproduce na sa saliva ay inactivated form. Okay? So of course, ingestion of fats happens in the mouth, okay? Happens in the mouth, but the lipase produced by the saliva is inactivated in form. Okay? So ayan, magko-combine ngayon yung lipase or yung lingual lipase together with the feed or the fat present in the feed. It is swallowed, pupunta siya sa ating sa stomach, no, sa stomach ng non-ruminants or monogastric animals. And then sa stomach may production na naman ng gastric lipase. So, meron na namang enzyme na lipase. But we call that now your gastric lipase because it's produced in the gastric gland, the stomach. No? Okay? So, yung acidic environment ng ating stomach, that will now activate yung lipase or yung lingual lipase produced in the saliva of the mouth. Okay? So, ayan, may partial hydrolysis or partial breakdown ng lipids that happens in the stomach, but to about 30% lang na ang nangyayari na hydrolysis dito. Kasi hindi yun kaya ng lingual lipase and gastric lipase lang. Kaya ang nangyayari is dito sa small intestines. Okay? Hindi lang kung maalala ninyo, much of the digestion happens in the small intestines for carbohydrates, for proteins, and pati na rin sa small intestines, sa lipids natin. Okay? So, ang pinoproduce na lipase doon sa ating small intestines, we call that as your pancreatic lipase because your pancreas is embedded in the duodenal loop. Okay? So, yun yung tumutulong. Okay? That will now help further, okay, yung digestion or breakdown ng inyong lipids. Okay? Now, before that, we have yung tinatawag nating emulsification, no? Emulsification of fats with the help of your bile salts produced by the liver, and that is stored in the gallbladder. Ang role ng emulsification of fats is ini-increase niya yung surface, kung makikita ninyo dito, ini-increase niya yung surface area of fats, no, doon sa small intestine. Okay? By making them into smaller, or by grouping these fat globules, or we call now this the fat droplets, into smaller clusters. So from this large fat globule with bile salts, with the addition of bile salts, magiging ganito na yung ating fat droplets. Okay? Magiging ganito na yung itsura. Okay? Yun yung role ng bile. Okay? Yun yung, kapag sinabi mo kasing you emulsify the fat, meaning to say, you change the environment so that yung fat and water can mix together. Kasi alam naman natin na naturally, yung fat and water will not really mix together. Okay? Hindi sila magmi-mix. Pero kapag sinabi mong emulsify yung fat, you change the environment so that yung fat and water can mix together more easily. And that is done or performed by yung ating bile salts produced in the liver. Okay, sometimes we call this as bile acids. Okay, bile salts or bile acids. Now, kapag kasi, so yung of course, yung bile salts, they enter, no? Kung makikita ninyo, they enter the small intestine. Okay, kapag nag-mix, no? Or kapag nag-mix yung bile salts produced by the liver in the small intestines, that will now start yung emulsification of fats. And kapag mas smaller na yung molecules or yung fat droplets natin, mas madali na lang kay pancreatic lipase na gawin yung digestion of lipids or yung breakdown ng lipid molecules or yung fat droplets. Kaya, ang end result would be, of course, still the basic building blocks, the production of smaller units or ng building blocks na tinatawag nating fatty acids, or sometimes they call that as monoglycerides. Okay? And since doon din nangyayari, doon sa small intestine nangyayari yung digestion, doon din nangyayari yung absorption, no? Absorption of the basic building blocks or of the fatty acids. Now, in the case of ruminants, ang meron sa ruminants, okay, is rumen, of course. Okay, so yung presence of rumen or presence of microorganisms in the rumen, sila yung tumutulong na i-hydrolyze ang fats rather, or ang lipids. Okay, so dito sa diagram na to, dineretso hanggang small intestines. So that is may kulang dito sa part na to. So dapat merong reactions na nangyayari dito, or meron pang diagram na nangyayari dito sa rumen. So to compensate for that, we have here dito. So yung diet kasi ng ruminants ay konti lang, no? Konti lang yung fat na nandoon sa diet ng animals. Because yung kanilang diet ay mostly grasses, no? Mostly grasses. Konti lang naman, no, ang fat present in grasses. But yung fats or yung fatty acid na present doon sa grasses, doon sa cereal grains ay high in saturated fatty acids. So mas mataas yung concentration ng unsaturated fatty acids kaysa sa saturated fatty acids. Okay? Ngayon, ang ginagawa doon sa rumen is, ang ginagawa ng mga rumen microbes or yung mga bacteria present in the rumen is to hydrolyze. Okay? Hydrolyze meaning to say, i-break down, no? I-break down itong fat molecule. Kaya ang nangyari, after ang product ng hydrolysis ay nahiwalay yung glucose doon sa fatty acid. Di ba ito yung basic unit, no, ng fats or ng lipids? So we call this now, since yung product ng hydrolysis, we call this now as the glycerol, and yung unattached fatty acid doon sa glycerol, we call that as your free fatty acids. Okay? Free fatty acids kasi na-free siya or nahiwalay, unattached siya doon sa glycerol molecule natin. Okay? So, ayun yung nangyayari. And then, yung glycerol natin or yung glycerol natin, it is readily metabolized, okay, by rumen microorganisms or rumen bacteria to form propionic acid. Kaya kung mataas yung level or proportion ng fat in the diet of ruminants, mas mataas yung production ng propionic acid. Okay? Pero ayaw natin yon. Ayaw natin yung mataas na proportion ng propionic acid because if you recall in your volatile acid production, mas maganda na mas mataas yung proportion ng acetic acid. Okay? So, ayun. Kaya, we started with low. No? So, sabi natin, yung diet ng animal is low in fat. Okay? Para mas konti lang din yung ipoproduce na, tawag dito, propionic acid from glycerol. And then yung free fatty acids, no, na produce upon hydrolysis will undergo biohydrogenation. Ito yung tinatawag nating biohydrogenation. Ang ibig sabihin lang nun, yung unsaturated fatty acid natin matatransform into saturated fatty acid. So yung ating double band na fatty acid magiging single band na lang siya. Okay? Further elaborate, ganito siya. Yung ating unsaturated fatty acid mag-undergo ng sino yung magpa-perform ng role ng biohydrogenation. Yun pa rin ating rumen bacteria because biohydrogenation happens in the rumen. Okay? So, ang mangyayari is, by the way, bakit kailangang i-perform yung biohydrogenation? Di ba sabi natin mas maganda yung unsaturated fatty acids kasi mas madali siyang i-breakdown. Kapag kasi transform natin siya or kinonvert natin yung unsaturated fatty acids into saturated fatty acids, mas magiging stable siya. So, gusto natin, in the case of ruminants, gusto natin more stable form yung ating fatty acids. Kasi too much unsaturated fatty acids, okay, can be toxic to our rumen microbes. And ayaw natin iyon. Okay? Now, aside from biohydrogenation, meron din tayong tinatawag, so hindi ko nalagay dito, meron din tayong tinatawag na conjugated fatty acid formation. Still dito pa rin sa rumen. Ang ibig sabihin ng conjugated fatty acid formation is ina-alter lang natin yung position ng double bonds. Okay? Double bonds ng alin? Ng unsaturated fatty acids para mas maging stable sila. But, magiging trans fat na ang tawag natin sa kanila. Okay? Magiging trans fat na sila. Yung ating unsaturated fatty acid. So, ibig sabihin, yung cis na formation, magiging trans na formation. Alright? So, yung double bonds present in the unsaturated fatty acids will not be separated or will not be hydrolyzed, will not be broken down to become these saturated fatty acids, but ma-alter lang. Okay? Mag-iiba lang yung position ng hydrogen bonds or nung hydrogen atoms natin. Okay? Yun yung nangyayari. Kaya, meron tayong napoproduce na trans fat galing sa karne ng animals or sa meat and even in dairy products. Okay? And then, yung procedure or yung process na nangyayari sa absorption and even in the digestion that happens in the small intestine, pareho lang ang nangyayari doon sa non-ruminants or doon sa ating monogastrics. Okay? So, same lang din sila. Absorption, final digestion happens in the small intestines and absorption also happens in the brush border of the small intestines. Okay? Proceed tayo sa lipid metabolism. So, this is our last slides. Yung lipid metabolism ay kinocomprise na yon yung beta oxidation. So, nangyayari yung metabolism of lipids, most especially kapag kulang yung source of energy for the animals. Di ba nga, one function of lipids natin is to supply energy. Kaya nangyayari yung beta oxidation process to break down yung ating fatty acid into acetyl-CoA units. Okay? Yung oxidation occurs in the mitochondria and not in the cytoplasm. Okay? Ang nangyayari lang na process doon sa cytoplasm natin is, if you recall, yung ating glycolysis. Okay? Yung ating Krebs cycle or your triboxylic acid cycle happens in the mitochondria. Same with beta oxidation process. It occurs in the mitochondria of the cell. And nangyayari yung beta oxidation, paano yung nangyayari? It shortens yung carbon chain natin into smaller. Okay? So, we start with a double bond. So, una, of course, para ma-reduce natin ang number of carbon atoms, i-hydrolyze muna, no? I-break itong double bond na to para maging single bond. Okay? Kung magiging single bond yan, ganito yung itsura. Meron na tayong OH dito. Okay? What else is, ayan, habang nagpo-proceed or habang nagpo-progress ang steps, nare-reduce ang number of carbons. Okay? Nare-reduce ang number of carbons. So, we have here fatty acyl CoA shortened by 2 carbon bonds. And then, still, the cycle repeats. Okay? The cycle repeats. Yun yung beta oxidation process or yung lipid metabolism. Nangyayari ang lipid metabolism most especially kapag kulang ng carbohydrate sources or glucose sources for energy purposes, okay, na need ng animal. Okay, so that would be all for the discussion on lipids. So tapos natin yung structure ng lipids, may hydrophobic na part, may hydrophilic na part, yung function, major function ng ating lipids is supply energy apart from being a component of your cell membrane. And we also discussed yung classification of lipids. We have the simple lipids, compound lipids, and derived lipids. And bakit kailangan natin mag-add ng fats sa animal diet, etc. to of course improve the performance. And lastly will be is the digestion of lipids, absorption, and metabolism of lipids.